In stats today, we looked at how to do a one proportion z-test. So on the state step, we've been practicing that. That's where we write p true proportion of whatever it is we're studying. We've been practicing that for quite a while, since chapter 8. The hypotheses need to be something like this. Always equal, and then HA will be either less than, greater than, or not equal. And then whatever the claim is. Level of significance, this is alpha. Let me write a better alpha. So whatever that is, it's typically .05. But it could be anything. For the plan step, we already know all those from chapter 8. It needs to be a random sample. And the large counts condition needs to be true. We go back to chapter 7 for this. This is kind of confusing because in chapter 8, confidence intervals, we had hats on those p's. But this p right there is whatever this claim is up here. It's going to be confusing because down here on the do step, we'll have a p hat value because they'll take a sample and they'll get a p hat and we'll type in what happened. And we're used to using p hat because we just got done doing it with confidence intervals last chapter. But for this one, we're going to plug in the claim. And then if it's true, we'll say, you have to check it, you have to literally plug it in. If true, sampling distribution is approximately normal. There's that third condition that I usually skip, and that is the n, the sample, needs to be less than 1/10 of the population. It's still very true. It is an important condition, but they rarely check it, require you to check it. It totally depends on the population size. We'll look at some problems down the road where that condition comes into play. For the do step, we're going to write down whatever p hat is. Should we make it all blue? That's bothering me. So we'll write down whatever the p hat is. We'll say it is a one prop z test. The formula, that's p hat minus p over p times 1 minus p over n. And then we'll write down whatever the p value is. Calculator will do that for us. Also, compare p-value to alpha. And then that'll lead us to the conclude step. On the conclude step, if p is less than alpha, we will reject HO, and we'll say something like evidence suggests HA, whatever HA says up there in the state step. If P is greater than alpha, we will fail to reject HO. Evidence does not suggest HA. All right, let's give one a try. And it is the potato problem that we've been working with. So we already know the state step. Maybe hit pause and read through it. I'm going to dive right in. For the state step, we need to write what we're measuring. We wrote this last week. True proportion of potatoes on the truck with blemishes. We set our hypotheses to P equals 0.08, and we're worried that that proportion is larger than 0.8. Something else that's important, it's thought of as good practice to put alpha in your state step. I've never talked about this before because we haven't done a test yet, and it's typed up there in the problem for us, so we need to just put it up here in the state step. Technically, you're supposed to set that before you take a sample, because that'd be thought of as manipulating your data if you don't. So, like manipulating the result so that you reject or fail to reject, and that's bad. So now on the plan step, we look through the paragraph and we see that a random sample was taken. N was 500. So we're going to go NP greater than or equal to 10 in 1 minus P. Now this is confusing because we do see a P hat. We're going to use it on the do step over here. P hat is 47 out of 500. I am not using that yet. On the confidence interval chapter, we did. We used it on the plan step. But anytime you have a claim, you want to use the claim, because we're making this hypothesis based on that claim. So 500 times 0.08, and I believe that is 40, which makes this 460. Therefore, sampling distribution, I'm running out of room here. I need room for a conclusion. Is approximately normal. All right, on the do step, the calculator is going to tell us that p hat value, so I'm going to hold off on writing what that decimal is. We're going to do a 1 proportion z-test, which is z equals p hat minus p all over square root of p times 1 minus p over n. Calculator is going to do all the math for us. So let's give it a shot. You press menu, stats, stat tests this time, and we want a 1 prop z-test. If you accidentally click z-test at the top, you'll hopefully see that's the wrong choice because it asks for a mean and standard deviation, and we don't have that. So you click 1 prop z-test. This is our hypothesis, 0.08. There were 47 potatoes with blemishes, 500 potatoes, and we suspect greater than. And some people just naturally write everything down. This calculator is kind of nice because it tells you p-val for p-value. Notice right below it, it says p-hat. There's a tiny little hat over it. That's our sample proportion. And then n. O and z. Make sure you write down z. So I know this p-hat was 0.094. I know z came to 1.15 39. And the textbook way to write this, we've been doing this since the fall, would be like this. Proportion of z's to the right of that z value is the p-value, 1243. That is the p-value right there. That's the final number we've been working for, the p-value. We need to compare that to alpha. You can do it in the do step or the conclude step. I usually do it right away in the do step, and it is larger than alpha, which means that p-value, this number, let's change colors, this number right here is being compared to this number right here, and that dictates how we conclude. I am now no longer looking at anything else on the board. I am only looking at those two numbers. Since P was larger than 0.5, that means it's not significant. We're not shocked. This isn't a rare occurrence or anything because it's not a small p-value. That means I am going to fail to reject. So conclude. Fail to reject HO. Evidence does not suggest the true proportion of potatoes with blemishes is greater than 0.8. All right, if you can't read that, fail to reject HO. Evidence does not suggest the true proportion of potatoes with blemishes is greater than 0.8. And that's it. See y'all in the next video.